Hi friends, I'm Yuvasri from second year CACB department in Kongunadu College of Engineering and Technology. Here I am going to show the PPT and explain the topic of interprocess communication as shortly known as IPC and how the process exchanges the data and synchronize effectively. The short note of IPC is explained in the before and after slides. The interprocess communication is nothing but the IPC allow the process to exchange the data and synchronize the actions, essential for multitasking, distributed system and parallel computing, used in modern operating system, cloud computing and AI driven flows. As per the statistics, 90% of modern operating system rely on IPC for process management. Why the IPC is important? The key reason for IPC is exchange the process collaboration, manage the shared resource, boost the efficiency essential for OAS abilities. Exchanges the process collaboration is nothing but enable a complex computing environment and managing the shared resources is to prevent the race conditions and the data corruptions. Boosts efficiency is facilitate the fast process execution and communication. Essential for OS stability is prevent the deadlock and the resource conflicts. Types of IPC mechanism is pipes, message queues, shared memory, socket signals. Pipe is unidirectional and bidirectional communication. Message queue is asynchronous process messaging. Shared memory is fastest IPC method requires synchronization. Socket is network based interface communication. Signal is event notification system for a process management. Pipes. It's a streamlined data flows. How pipe works? It allows the communication between the related processes can be analyzed and are named. Commonly used in Unix and Linux shell scripts like to call upon the temporary or an persistence. Example Linux command. What are message queues? Process send and receive the structured message via queues. Ensure that the communication even if the receiving process is unavailable. Used in a large scale distributed computing, for example, cloud managing service. Shared memories and the databases. The process accesses the shared memories and the same space for a ultra fast communications. It requires synchronization tools like mutex and semaphores to avoid the conflicts. The ideal for the high performance computing and the databases. For example, the Oracle and MySQL database use a shared memory for the fast query executions. Socket and network based communication. The socket enables the IPC between the processor across the different system via internet. Used in a client server models like HTTP, FTP and WebSocket. Support TCP is reliable and UDP is fast but less reliable. Example web browser and chat app and chat APT. What are signals? Used to notify or control the process asynchronous commonly in Unix and Linux for the handling process, terminating and alerts. Limited data transfer mainly for an event triggerly common signals like interrupt, foreshop, terminating process. The synchronization is important or not? The reason is it is important because it prevents the race condition when the multiple process access shared data. It ensures the data consistency across the processes. It's the common synchronization technique or basically three. One is mutex. It is popularly known as an mutual exclusion. It prevents the simultaneous access to shared resource. Semaphores. It allows the controlled access to resource like counting misses binaries. Monitors. It encapsulates the synchronization logic in high level programming. The key difference between the pipes and the managing queues. Its features are speed, persistency, communication, and memory usage. Pipes is first come, first out, and message queues. The speed pipe is faster for a small data. In a message queue, the speed is more efficient for a large data. Persistency data lost, data remains until it receives. Communication, parent and child process. Any process can communicate it. Memory usage, less memory usage, require query and queue communication. Storage. Advanced IPC shared versus socket. Choosing between the shared memories and the socket. The shared memory is fast IPC methods, ideal for high-speed applications, and it's only one conflicts and the only one disadvantages are need synchronization mechanism to avoid conflicts. In socket, enable the network-based communication even across devices. Used in a cloud computing and distributed system. The only one disadvantages are slower than shared memory due to the network ahead. In real-time IPC, ensuring the low latencies used in an autonomous vehicles and socket and trading and robotics require a microsecond level latency for decision makings. The technique for real-time IPCs are zero copy shared memories, high performance message queues and low latency sockets. IPC security challenges and the solutions. The common IPC security risks are race condition, IVs droppings, denials of service. In race conditions, two processes modifying the shared data at the same time. They are the most common IPC security risks. And IVs dropping is unsecured IPC channels can leak the sensitive data even though the more sensitive data can also be leaked due to the unsecurity IPC channels. Denials of services DOS, malicious process can flood IPC resources. Solution: Access control list, data encryption, process sandboxing. Access control list restricts the IPC permissions and the data encryption protect the IPC message from the interruptions. Process sandbox prevent the unauthorized IPC interactions. For the statistics in 2023 about the computer and cyber security journals, over 60% of OS vulnerability are IPC related. Distributed IPC communication across the networks are how the distributed systems used in IPC involve the process communicating over a different machines via internet used in cloud service, IoT machines and microservice architecture. The popular distributed methods are robotics and remote procedures, message brokers and REST and WebSockets. The remote procedures calls enable the function calls across the machines and message brokers handle the massive data exchange and REST and WebSocket used in the database IPC for real-time updates. How AI and quantum computing will change IPC. The AI optimized quantum networking and 5G beyonds are used to change the IPC for computing the quantum and AI because the AI optimizing IPC predict and optimize the process of communication path and quantum networking use the quantum entanglement for an instantaneous IPC and 5G and beyond enable the ultra low latency IPC in a mobile and engaged and edged computings. In the statistics of 2023, according to the MIT, AI driven IPC can reduce the process communication over by a 60%. Where is IPC used? The operating system task scheduling the process synchronizations, web browsers, database, cloud computing, and gaming AI. The challenges are synchronization overhead, security risk, and performance bottleneck. Synchronization overhead is maintaining a multiple process in complex. Security risk is IPC channel can be vulnerable to attack or shared memory exploits. It leaks a sensitive data that's make a security risk. Performance bottlenecks is poorly optimized IPC, slow down the multi-core processors CPUs. The future trends in IPCs are AI-driven IPC, quantum computing IPC, and high-speed networking like 5Gs beyond the ultra-fast process communications. As per the statistics in 2023 by the MIT, the AI-driven IPC optimization reducing the processing delay by 50%. The IPC is the foundation of modern computing. It is essential for OS, cloud computing, AI generation, and distributed systems. The future IPC will rely on the AI quantum computing and high speed networking. The world run on IPC in every second. Thank you for being watching the videos till the end with your smile. Continues on the next videos.